This introduction to Python series is part of the EPSCoR Track 2 DDMD workshop. This presentation will be a brief introduction to natural language processing. Natural language processing is about developing applications and services that are able to understand human language. There are millions of gigabytes generated every day by blogs, social websites, and web pages. There are companies gathering all of these data for understanding users and their passions and give their reports to companies to adjust their plans. These data could show that people in Brazil are happy with product A, while people in the United States are happy with product B. Some of the platforms that implement natural language processing are search engines like Google, social websites like Facebook and Twitter, speech engines like Apple Siri, and spam filters, where spam filters are able to examine emails and determine whether or not that email is spam. We're going to implement some simple natural language processing functionality using Python's Natural Language Processing Toolkit. This toolkit is the most popular library for natural language processing that's written in Python, and it's easy to learn. One of the functions made available in the Python Natural Language Toolkit is word tokenize, and word tokenize will tokenize a string into tokens. So in our example, we show how we import word tokenize. We initialize data to a string, a sentence, all work and no play makes Jack a dull boy, all work and no play. We call the function word tokenize and we pass that string in as an argument. The function returns a list of strings that represents tokens. The last line in our code, we take that string and we use the split method to split the string into substrings based on a space. So it'll split it up and return a list of strings that were separated by that space. And I want to compare the two results. So if you look at the first line of output, we see a list of strings that was returned by word tokenize. And the last line of output is a list of strings that were created by using the string split method. Notice specifically at the point where we have boy, when I do a split, the comma becomes part of boy, but the tokenizer knows that the comma isn't part of the boy token, and it splits it into two tokens, boy and comma. Here's another example of using the word tokenize function to tokenize a string. The string that we're using as an argument in this example is longer and contains more special cases than our previous example. As we examine the output from tokenizing our string, there are a few things to note. First, notice that the punctuation is treated as special tokens. So we have our question mark, our period, our comma. Notice that Mr. Period, the period is not separated from Mr. So the tokenizer knows that MR period is a complete token. Also notice the separation of the word shouldn't into should and an apostrophe T. And finally, notice that pinkish blue is treated as one word, as it's meant to be. The Python Natural Language Toolkit provides functionality for stop words. Natural language processing is a research field that presents many challenges, such as natural language understanding. Text might contain stop words like the, is, are. Stop words can be filtered from text to be processed. There is no universal list of stop words. However, the Natural Language Toolkit module contains a list of stop words, and frequently we want to remove those words from the text that we're processing. Here's an example of how we might leverage the Natural Language Toolkit to acquire a list of stop words. So in this example, we import stop words from the Natural Language Toolkit corpus. Then we call the stop words .word method, passing in as an argument English. So basically we're calling this method asking for a list of stop words that are in English. This function returns a list of strings that represent stop words. We assign that to the variable stop words. We print out our stop words just to get a feel for what is in this list. And we can see by examining this list what constitutes a stop word. Here's an example of code that can help us to remove stop words from a string. So we start by importing word tokenize and we import stop words. Then we acquire a list of stop words using the stopwords.word method, and we assign it to the variable stop words. So now stop words is a list of strings representing stop words. We initialize data to our sentence. Then we tokenize that sentence. So our tokens is now a list of strings representing tokens that were created from our sentence. What we want to do now is we want to take our tokens and we want to eliminate all the stop words from the tokens. So we're going to initialize a list called filtered words, and we're going to initialize it to the empty list. Then what we're going to do is we're going to look at every token in our list of tokens. And if that token is not a stop word, we're going to add it to our filtered words. So for each token in our token list, we're going to see if it's a stop word. To do that, we're going to say if a token is not in stop words, if that's true, then add that token to our filtered list. So filtered words dot append and pass in that token. We're going to process every token in our token list. If it's not in stop words, we're going to add it to our filtered words, and then we print out our filtered words. Now, if you notice, we have a small problem. Most of the words look pretty good. Addition, information, need, presented automatically. So those are our tokens that are not stop words. But we have a couple of problems. We have a comma in there, and we have a stop word. Uppercase I-N, in. Surely that's a stop word, so why didn't that get filtered? All of the strings in our stop words list that represent stop words are in lowercase. Therefore, when we have a stop word, uppercase I-N, and we compare that to the stop word list, and in the stop word list is lowercase I-N, asking whether or not those two are equal, that returns false, because uppercase I-N is not equal to lowercase I-N. Therefore, in order to be able to remove the stop words from our data, we need to convert our data to lowercase. So we've added a line of code, and I have it highlighted there, where we call the method lower on our string data.lower, and we assign that to data. We've converted our data to all lowercase. Now when we execute our code for filtering out the stop words and we print the filtered words, we see that uppercase IN no longer appears in our list. Another concept in natural language processing includes the concept of stemming. A word stem is part of a word. For example, the stem of word waiting is wait. So you can see we have waited, waits, waiting, and the stem of all three of those is the word wait. Our natural language toolkit provides a module to help us deal with stemming. So we import the Porter stemmer from the natural language toolkit.stem. In this example, I create a list of strings, wait, waiting, waited, waits, and I assign that list to the variable words. Then I assign the variable PS to Porter stemmer. Then for each word in our words list, we're going to stem it. So PS has a method called stem, and it expects a string as an argument, and it'll return the stem of that string. So for each word in the list, I stem it, and you can see with each one of them, the stem is returned as wait. Lemmatization of words is similar to stemming. The difference is the result of lemmatizing is a real word. When you try to stem some words, the results might be something like this, where we try to stem the word increases, and the value that's returned from the stem method is INCREAS, which isn't a real word. So instead of stemming, if we lemmatize the word, we get a result similar to this, where we import the WordNet lemmatizer and we call its method lemmatize. So if we lemmatize increases, we get the word increase returned as a result. Here's some examples of the differences between stemming and lemmatizing. So if the original word is discoveries, the lemmatized word is discovery, where the stemmed word is DISCOVERI. Involving, the lemmatized word is involving, and the stem word is involve. So this just gives you an idea of the difference between lemmatization and stemming. Let's develop a simple natural language processing program. We're going to write a Python program that'll read text from a file and create a list of unique, stemmed, nonstop words. This list of words should be printed to an output file. So our input file is going to be text. We're going to process it by removing the stop words, lemmatizing the terms, and identifying all the unique terms, then writing those terms to an output file. Our algorithm will include reading text from an input file, tokenizing that text, filtering the tokens by removing the stop words, filtering the tokens by only keeping the unique stemmed words, and then printing that filtered token list to an output file. Here's an example of a function that reads text from an input file and returns a token list. So the name of our function is tokenized text, and the parameter is an input file name. and it's going to return the text that it reads from that input file and returns it as a list of strings representing tokens. So we open our file for reading, and then we read the file. And if we do abstract_file.read, it reads the entire contents of the file as one string, and we assign it to abstract text. Once we have abstract text initialized to the text from the input file, we can tokenize it by calling the word tokenize function and passing the abstract text in as an argument. And that function returns a list of strings representing tokens, and we return that list to our calling program. We have our try except block to guard against any errors, and if we encounter an error, we're going to return the empty list. Just for testing purposes, I printed out a list of tokens that was returned from calling our tokenized text method. And here's an example. Here's an example of a function that'll remove stop words from a list of tokens. So our function name is remove stop words. The argument is a list of strings representing tokens, and it's going to return the token list with the stop words removed. First thing we're going to do is initialize our stop words list by calling stop word method. Now we're going to create a filtered tokens list. We initialize it to the empty list. Then for each word in our tokens list, we're going to check to see if it's a stop word. And if it's not a stop word, we're going to add it to our filters token list. So for each word in tokens, if word.lower is not in stop words, then append it to filtered tokens. After we've processed each token in the tokens list, we have our completed filter tokens, and we're going to return our filters tokens, which is a list of strings representing tokens that are not stop words. Here is an example of tokens that might be returned from our remove stop lists function call. Now we need functionality that'll help us to filter these tokens by just keeping the unique lemmatized words. So we're going to initialize the lemmatized filter list to the empty list. And then for each word in our token list, we're going to lemmatize it. Then if the word is not already in the lemmatized list, we're going to append it. Here is an example of a function that will filter a list of tokens by only keeping the unique lemmatized words. So the name of our function is create unique stems. Our argument is a list of strings representing tokens, and the value that this function is going to return is a list of unique stem strings using lemmatization. The first thing we're going to do is create our lemmatizer, and we're going to initialize our lemmatized tokens list to the empty list. Then for each word in our tokens list, we're going to first lemmatize it. So we're going to call our lemmatize method of our lemmatizer, passing in the word, and it's going to return that word after it's lemmatized it. We're going to take that lemmatized word and we're going to check to see if we've already added it to our lemmatized token list. If it's not already in the list, we're going to add it to the list. So if lem word not in lemmatized tokens, if that's true, then lemmatized tokens dot append lem word. Once we've processed all the tokens in our list, so we've lemmatized them, and then we've checked to see whether or not they're already in our list, and if they're not, we add them in our list. So after the termination of that for loop, we have a list of unique lemmatized words, and we're going to return that list to our calling program. For testing purposes, we print out the list of unique tokens that are returned from our create unique stem function. We see that we still have a problem. This list of tokens includes punctuation marks. We see a colon, we see a greater than sign, we see a comma. So we want to deal with those problems. To remove punctuation marks from our token list, we can add a condition in our create unique stem function. So before we add a token to our lemmatized token list, we can make sure that it's an alphanumeric token. So in our condition, we say if the lem word not already in the token list, so not in token list, and word is alphanumeric. So that's a method of a string that returns true if the word is alphanumeric. Colons, commas, quotation marks are not alphanumeric, and it would return false, and therefore that token would not be added to our list. Here's an example of our list that's been tokenized from an input file. It's been lemmatized, the stop words have been removed, and all the punctuation has been removed. The last thing we need to do is to write these tokens to an output file. We're going to write a function that receives the name of an output file and a list of strings. In this function, we're going to open the file, and then for each string in the list, we're going to write it to the output file, and then we'll close our file. Here's an example of a Python function that'll create our output file. So the name of our function is output list. The arguments are a string representing the name of our output file and a list of strings. Notice that this function does not have a return value. Nothing is returned to the calling program. First thing we do is we open our output file and we assign it to the output file handle. Then we process through our list of strings, and for each string in the list, we write it to our output file. So we do output file.write, and we pass it in that string. Notice that we append a \n, which is a new line feed, to the end of our string to guarantee that these strings will be printed one line at a time. When we've processed our entire list, we close our file. We use our try except block just to ensure that if we're not able to open our output file, we can print an error message to our user. Now we've completed all of our functions. We're ready to write the main portion of our program. The problem statement was to write a Python program that will read text from a file and create a list of unique stemmed nonstop words, and this list of words should be printed to an output file. So first we're going to call our tokenized text function, and we're going to pass in the name of the input file that has the text we want to process. This function will return a list of tokens from that text. Next, we're going to call our remove stop words function, passing in our tokenized text. This function will return our list of tokens with the stop words removed. Then we're going to call our create unique stems function, passing in the tokens without the stop words. This function will return a list of tokens that have been stemmed and that are unique, and we've had the punctuation marks removed. So these are the lemmatized tokens. Now that we have our list of unique stemmed nonstop words, we can write them to an output file. So we're going to call our function output list, passing in the name of the output file that we want to have created, and we're going to pass in this unique list of tokens. Here's an example of what the final output file might look like.